All right, so question number 3 on page 296 says, or excuse me, question number 5 says, the electric field at a point in space has a magnitude of 100 newtons per coulomb and is directed to the right. If an electron is placed at that point, what force and acceleration would it experience? So what we would have is we would have an electric field pointed to the right of E, and that's going to be 100 newtons per coulomb. Then, if we have an electron there, remember that an electron experiences a force in the opposite direction, or a negative charged object experiences a force in the opposite direction of my electric field. That's because an electric field points in the direction of the force that would be acting on a positive charge. Now, what we know is that the electric field is equal to the force per unit of charge that's in there. And so if I want to solve for force, then I'm simply going to rearrange that equation so that we have force equals electric field times the charge. Plugging my values in then, I'm going to have 100 newtons per coulomb times a charge of 1.6 times 10 to the negative 19. Looking at that then, since I'm just multiplying this number by 100, I'm going to move my decimal place 2 points to the left. So instead of a negative 19, the force that it would experience is simply going to be 1.6 times 10 to the negative 17 newtons. So that's my force. The second part of the question simply asks, what is the acceleration that it would experience? And so we're going to use Newton's second law of acceleration equals force over mass. And say, well, the force is 1.6 times 10 to the negative 17. And my mass is going to be 9.11 times 10 to the negative 31st kilograms. So when we divide those, we're going to get an acceleration equal to 1.76 meters, 1.76 times 10 to the 13 meters per second. That would be its acceleration. All right, so again, we see that this is our magnitude of force. We're going to know that our force is going to point to the left because it's going to point opposite our electric field, and then it's going to accelerate at this rate. If we had a proton here, our force would actually be the exact same thing because it's the same field, same charge. However, our force would point in the opposite direction. Our acceleration would actually be much smaller because of the mass of the proton being much different.